All right.
Okay.
Off and running.
Thanks. Yeah, so transforming work with AI and ML. Uh, our agenda for today, I already did the intro, but I have a few more sort of introductory comments to make on the topic. We're going to look at, why do we care about this? Why is this maybe important thing to be thinking about? We'll look at getting started, which sort of presupposes like the case is going to be validated and you'll accept my thesis that you should be getting started with it. And then we'll look at some real world examples of people that are doing this. And I'll be pausing for questions along the way. Sometimes when I'm presenting and talking, I can't see hands or whatever. If you do have one, you can always blurt it out and interrupt me. Feel free to do that. Like Pat said, very, very informal. But I'll try and pause for water and for questions as I'm talking. Okay, so we did that already. What are we looking at? Not a slide deck. We're looking at a Jupyter notebook. This is a really important, probably like one of the core tools for machine learning and data science. I would think most of you have probably seen something like this before. I think it's a great tool. It's like one of my very favorite tools to use now that I've been in it much more often. It's great because you can run individual chunks of code. You can put in Markdown that ends up looking like a web page, kind of like most of what this presentation is. You can put in charts. It's flexible, powerful, and it's free, which is awesome. One slight drawback, there's a few slight drawbacks, but one in particular for our purposes, no spell checker, so sorry if I mistype anything. Just gonna move this over a little bit. Okay. Now, Pat said, when I talked to him and I shared this deck with him, he said, hey, make sure you focus on the stories and the takeaways more so than the technical a little bit. But so I'm going to do that. But I also want to make sure that if you're curious, you have a way to an easy way to step into this and start exploring it yourself. Okay. So what I'm going to do at the end of the presentation is I'm going to upload this notebook file into the Teams chat, and you can download it and do what you like with it. All the hyperlinks that I have in here will be included, along with some steps and instructions about the content we go through. So be giving that to you as well. Why is this important? Well, I think even if you're a business user and thinking about sort of exploring one of these ideas yourself, it's good to have context for how the work gets done. And so if you haven't seen this before or aren't super familiar with some of the tools like Python or things like that, hopefully it helps you, like I said, get acclimated with that. So that's my hope in presenting it this way. Also, I like working with it, so it's easy for me. And then really, kind of like I said before, why include this? Well, I think to successfully understand it, you got to understand the basics, right? Just like a lot of things in life. So first break, any questions before we make the case for how we transform work with AI and ML? Okay. So this nice quote that we have here is from Pat and Bryan when they put together our sort of synopsis for our talk. So you should see that on your invites. But I think it's really accurate. I included it because I think it's a good way to start focusing in on what we want to be thinking about here. Obviously, there's a lot of buzz with AI and ML right now. And I think sometimes it can be easy to think, oh yeah, sure, people are doing things with that, but that's not something that my business is going to do or that my team's going to do. And the reality is, it's not far off. And like I said, we'll look at some examples later of um, you know teams really getting into their first foray into this field. But the synopsis is really good, right? They're looking to grow revenue, explore new markets, enhance customer experiences, and AI and ML as a tool allow you to do that in new ways. Our firm, SPR, published this document this year, like a lot of consulting firms do, right? We have these technology predictions, and the one we're looking at, you can click on the link later if you want, but we're looking at transforming work with AI integration. And there's a couple quotes in here that I wanted to kind of pull out and just keep in mind as we're thinking about the topic. Um, you know, AI, machine learning integrated into daily work as a new standard, right? Particularly for knowledge workers. I think that's just about everybody on this call, at least who introduced themselves, for the most part, right? Organizations focusing on AI, but discovering, this potential for not just automation, but impacting other areas of their business as well, right? And I think the last part here, empower employees with new skills. Really, that's kind of why we're doing this, right? To learn some new skills. But newsflash, which I already kind of spoiled, but they're not predictions. This is a reality for some businesses, right? We're going to look at some cases later of companies doing this. I think in a lot of these cases, and this is something I see happening as I'm doing some of these projects and also talking to potential clients and things. I don't know if we coined this term or not, but we've been calling it assisted intelligence for a while, and the idea is sort of like you don't set up one of these tools and it just sort of goes off and lives by itself, unchecked or unmanaged. It kind of has a very almost hyper specific purpose in your organization's workflow. And you'll see how that fits in a minute, but you almost start thinking about it as a service, if you're sort of familiar with that mentally, of getting an answer from something, and that's really how you can kind of dip your toe in the water, as it were. So one other thing that I wanted to kind of think about before we hop into this was a brief story. Although this is mostly me telling stories, but this one in particular, I think, just happened like the day. I think it was the same morning that Pat asked me to come and speak to the group here, and it was just one of those sort of like kismet moments, I guess. But my boss was in town visiting me, and we were talking about what he'd been up to and stuff, and he told me that he went to a conference. He hadn't been to a conference in quite a while, and so he was telling me a little bit about it. And he said, "Yeah, the weirdest thing, we had a client there, and I wasn't expecting them, so I went to their session, and they spent about 45 minutes or so talking about this." Technical upgrade they had just made. And, I was sitting there the whole time thinking, man, that's like, why are you presenting on this? Like, this is ancient. This is old news, right? And he's like, you wouldn't believe it. He gets to the end of the talk and he says, okay, are there any questions? And there's a dozen hands that go up. And he's like, I was just astounded because this thing that I thought was like nobody's doing this anymore, right? Was like there was a room full of people who were like, I'm trying to do this. Like, not only are they doing it now, or maybe kind of doing it now, like they want to be where he is. And so I think the moral of the story for me as I was thinking about the talk and sort of the scope of it was like, as consultants, we're often doing that, right? Like we're writing things like technology predictions for 2024, and that's sort of part of the business and part of being at the forefront and being advisors, right? But at the same time, um, there's often like a gap between what you're talking about and what people are actually doing. And so my hope with the session is really to kind of reach a hand across that gap and help people maybe take the step into exploring ways that machine learning and AI could be useful for them if they haven't already. Yeah, Pat.
Kevin, regarding this phenomenon you observe with clients or prospects, do you think it's a typical bell curve on AI, just like for any other adoption cycles?
Oh, that's a good question. Um, I think it probably will be, but I think right now there's a lot of people in the boat that we're going to look at of I think I have an idea that could help my business, and I think AI might be the solution, or machine learning might be the solution. Um, and so I want to test it out very cautiously and see how that works. Um, and we'll see in a second that there is a little bit different sort of mentality to going through a project like that or going through that process than maybe typical software development. So I think to answer your question, like if you're thinking about the bell, I think almost everybody's kind of at the lower left, right? Like we haven't really started peaking, but I think in the next couple of years and kind of to what our article's talking about, you're going to start seeing it climb that curve.
I will say that makes sense on, yeah, I think there are several factors that are likely influencing adoption. One is fear, I think,
Yeah.
because AI
Yeah.
has the potential to really share either misinformation or false information. I forget that term they apply to AI. But in certain respects, it's a bigger risk, I think, than sorry guys, traditional technologies.
Yeah. For sure, good observation. In fact, to that point, the project that Kevin and I had just finished, we got to the end of it and we're very happy with the machine learning solution that we had built. And we started getting pushback from some of the users on it. And, the business sponsors and everything were excited about it and, very interested in bringing it to market, but a lot of the people who were going to be sort of asked to look at that information as part of their current workflow didn't really want to do it. And part of what we found out is that they were scared. They thought that there's all these articles in the news, like to your point of, oh, all these people are going to be replaced by AI, and they thought on some level that was kind of the goal of it. And in a lot of cases, and I think I'm glad you brought that up too, because I think that's part of this talk too, is just understanding what it actually is. I think helps you uh, minimize some of that fear and um, some of the confusion, maybe that, like, why did it do this? Kind of to your question. So yeah, it's a good point. Any other questions? Okay, well, let's get started. So, assuming we accept that um, assertion that I'm making there, that we're going to be able to transform work with AI and ML, hopefully what you're thinking is great. I want to work less and get more done, right? How can I get started with it and begin discovering the potential for my business, my team, whatever? We're going to look at a process here. I have used this process on a number of projects. It works well for me. I think it's my own creation. So it's sampled from a lot of people, from my peers. Shout out to Pat Ryan. I think Ryan or Pat mentioned that he had spoken to the group before, and he's sort of my Mr. Miyagi, as it were, of machine learning. But trainings I took, books I read, etc., solutions I built, all sort of bunched together to sort of refine the process. We won't dig in too deep to all the particulars. You're going to get the notebook, so you'll be able to take a look at that. But ideally, if you wanted to explore a machine learning solution, my hope is that you can take this script, as it were, and follow it through and get yourself to at least the result of an initial experiment so that you can decide what to do from there. And we'll look at sort of the steps involved in a minute. We're going to be using a public data set. It's called the IRIS data set. It's super popular. If you've done any machine learning reading or basics, you may have run into it already. But there's a lot of nice things about it that will, I think, help us learn some of the concepts, right? Plus, it's baked into the toolkit that I talk about installing here, so you don't have to install or add or download anything. It's just built in. And the IRIS data set is really measurements of flowers and being able to identify, like which flower you're looking at. Scroll up here so you can see this. Okay. So step one, start with a question. Okay. To me, this is where the data science term really makes a lot of sense, right? Try to frame your problem that you are thinking about in terms of a question that you can answer. This, I find at least, gives me a lot of clarity about how to stay on target when trying to solve the problem. Afterwards, and we'll talk about this at the end, you will answer that question, and then you'll have a chance to make a decision about what you learned there. So in this case, I wrote a quick sample hypothesis about our data set, and it's just sort of like we're going to, sort of imagine ourselves as running some sort of business where we care about the measurements of the flowers, and we'll say, well, if new samples collected, can we determine which type of iris we have without someone having to look it up in our catalog or query a database or something like that, right? Make it just sort of automatically detected, saving us time and maybe some money and effort, right? I put in a couple of these little notes, and I probably won't read them while I'm talking, but I hope as I'm talking, you're sort of thinking about these in the background as places where you can explore this in a little more depth. Okay, so once we have a hypothesis, then we need, of course, to do data science and machine learning, we need data. I think that once you have the hypothesis, like I said, the question, that sort of clarifies what it is you want to do. It also clarifies maybe the kinds of data you do and don't need. I think the two things to look for with your initial data set are that it's trustworthy. Okay, you know where it came from, it's accurate. You're able to use it, right? There's no security or personally identifiable information or problems like that with it. And I think it should be a manageable size. Like you could work with it on your computer. That's not to say you couldn't start with something bigger, but I find that especially if you're thinking about, this is the first time I'm going to try this, you want something very manageable. And I think that will help you or make your chances for successfully running the experiment much better. So I do a little bit of that here. We won't look into all the particulars of it. I just load the data set from our samples. We can look at it just like a spreadsheet. You can kind of see it here. We've got 4 columns, which we call features, and then we've got a target. Oh, I zoomed in, so it cut off part of my text. That's okay. Our target, which is what we're trying to predict. And we can also see we have 150 rows. So this is a nice small data set. It's well curated. We trust it. Very simplistic. Everything's looking really good at this point. One of the other nice things about, I just threw this in for funsies, but one of the other nice things about notebooks and some of the tools involved in machine learning basics are that you can make charts out of your data very easily. And so I just picked a couple of properties of our flowers, and we can see class 0. We'll look at what these numbers mean in a sec, but we can see that, you know, these all are kind of grouped together, and a lot of our purple ones are pretty close, and a lot of the dark blue ones are pretty close, but we've got these sort of kind of a mixed bag right in here. And that tells us that measurement-wise, these two can have some similarities. So that's kind of an interesting point and a bit of a spoiler, but just keep that in mind as we talk through this. Okay, so step 3, analyze and prepare the data. Most of probably the best way to like really just distill this down is that all AI and ML models are math. Okay, they're statistical algorithms. A lot of them are really complex, but they're still just math problems. So in that, because of that, you can't have null or empty values in your data, and you have to represent everything as a number. There's a lot of techniques for doing that. I provided some links here that you can use to go and learn more about them. But there's a lot of times this step, number 3, is the most boring and the most time consuming. You spend a lot of time getting sort of the data organized and prepared to be modeled. And the modeling, you'll see an example of a machine learning model in a sec, but much shorter amount of time. I think step 3 is often very time consuming. Okay. One other concept to put into play is called feature engineering. And this is the idea of like combining data that you have to make some new field. So I put a little example here where we might say, oh, our petal width is too granular at 0.2 centimeters, right? That's really, really tiny. I don't actually know how you measure petal width, honestly, but anyway, they measured it for this data set. So we might say, oh, okay, well, let's just make small, medium, and large buckets, and we'll decide kind of how what those numbers mean or what ranges fall into those buckets, but we'll sort of set up a grouping for ourselves. That's an example of feature engineering, if you hear that term. And then quickly, here's our 3 flower types. So if you remember up here, we had 0, 1, 2, and this list right here follows those. So these are the three types or species that are included in this data set. And conveniently, one of the reasons people love this data set is that there's exactly 50 of each of these. So they balanced it out extremely well, like as well as you probably can do. Okay, next step, run the simplest experiment possible. I sort of have this mental chart, which you can see right here. Really, your kind of decisions are supervised or unsupervised, really the kind of model you're going to pursue. Usually you want to use a supervised model to start, unless you have a really clear idea for like image classification might be a case where you wouldn't necessarily use that right away, or some kind of like computer AI, like Pat always used to do this demo of a teaching a car how to drive down a road and not go off the road. So something like that where it has to like learn patterns, that's probably unsupervised. And in a supervised situation, sort of like typical machine learning, then you have two types of predictions you can make, regression and classification. And the difference really to keep in mind there is that regression is going to predict a number, like rental fees, recommended premium, fantasy football points. Classification is like predicting a type or a group, or it could just be yes or no, right? Like flower species, which we're going to do in a second. So you have to decide what type of solution or model you're going to develop. But then you also just have to decide if you're going to build it or not. There's a lot of off-the-shelf products, especially from cloud vendors that you can use. And I've provided some lists here that you can check out. There's also this site called Hugging Face, if you haven't heard about it. There are a number of open source models out there, that are grouped together in what they call a zoo. And I don't know, it is a little bit, it's probably a really good term, I think, actually, because there's some wild stuff out there. Public service announcement, only you can prevent data breaches. Hopefully you've all heard this before and it's not new, but if I get a chance to talk to people about getting started with this, I always throw something in, and at least at SPR, we're constantly like reminding people of this. Using online or hosted models or services that have AI models is great. It can often help you get to a solution or exploring your hypothesis faster, but you got to be really careful what you send them, because a lot of providers will retain your data you send them for training. It's part of your user agreement, okay? So be very, very cautious what you post to any chatbot, GPT type solution, or really any of these hosted models. Make sure it's something you trust, right? Like we talked about earlier. How do you know if you should use one off the shelf or try to make one? I would say if you are building or think that you're looking at an unsupervised problem, you probably want to see if somebody solved it already. You know, like you training like any kind of like text-based model, large language model, image model is really expensive and time-consuming often. So I would say you probably want to see if you can use something off the shelf first. For supervised problems like general machine learning type work, I would say probably try using your own first. Unless it starts to become kind of complicated, you might have to pivot. But also, usually the more specific the data is to your business or your situation, the more likely building your own solution is the right place to start. Kind of like a lot of pieces of software. Okay, so we're going to build a really simple model right here. It's really just 4 lines of code. And this is a algorithm called k-nearest neighbors. And we just pass in our iris data set and say fit. And now we've got a model. So what do we do from here? We want to evaluate the results, right? We have to measure what we're doing. Again, there's a lot of machine learning metrics available. I've got some links here where you can go and explore those a little bit further on your own. I will say that for AI solutions, this can be a little bit harder to figure out because it's a little more difficult to see what's going on inside the black box. But there are some heuristics people are starting to develop to test these. Again, one thing I tell people that I do projects with, Kevin's heard this before, but I will say the first thing you should ask yourself is it likely that somebody else has had this problem? And the answer usually is yes. So you usually want to start by trying to see how other people have solved the problem before you go and, reinvent the wheel, as they say, right? So right here, I ran a little test and I picked a metric called accuracy score, and I put through a sample of each flower and I predicted the results. And you can see that our model did pretty good. It got the first 2 right and it missed on the last one. So we can say, all right, our first result was right around 67%. That's by high school grades, not so great. We'd like a little bit better grade than that. So the last step is really, well, how can sorry, trying to get it all on screen at once. What do I do from here, right? I have my result. What did I learn from that? What kinds of things could I do to make the experiment better? Maybe I need more or less data. Maybe I need a different ratio of samples. Maybe I could use a different algorithm, right? I told you I picked this one. Maybe there's another one that's better for my particular problem. All these things are questions to ask and explore further. I think probably the important thing to point out here is this thing in bold, and this is another thing I said a lot, but you have to remember that unlike other software projects, you don't start with requirements, you start with a question. So it's almost the inverse, right? And your goal is to answer the question or get more information to lead you to a new question versus to necessarily, I mean, you're going to build a solution too, but it's less about checking off the box and saying, yes, this form works. When I click submit, it posts my data and the data is saved. It's not really that kind of a project. And the other thing to keep in mind is that this is a circular pattern. Once you are evaluating your results and you decide on a new question, you probably start over unless your model first time through was excellent, which I wish I could say has happened to me, but it hasn't yet. And I think it usually doesn't. So oftentimes this is a circular pattern of continuous refinement and getting better results on future experiments. Oh, I spelled this word wrong. So this is what's great about Jupyter Notebooks. There. Oh, we're recording it. I guess people are going to see it anyway. Okay. Anyway, here's my summary. Following the pattern, repeat as needed. I did a lot of talking. What questions do you guys have about these, or things I should go back to? Then we'll talk about some case studies.
Not questions, but yeah, I agree. A lot of repeat in correct.
Awesome.
No one gets it in first attempt.
Yep.
Yeah. And sometimes what happens is I think of a word but don't necessarily type it. I, I just say to myself, I ate it.
Cool. Any other questions? Okay. Well, let's look at some real world examples. And when I wrote these looked really good on my computer, but then I realized that the text was kind of small, and I zoomed it in for the call, but now they don't fit on the screen quite as nicely. So we might just have to scroll through here together. So my point or my hope with the real world examples is to uh, spur some ideas. There's 4 case studies here, and it's all examples of companies and teams using AI or ML in their day-to-day work for the very first time, like the first group at the company that's doing it. And I think that it's likely that is a next step for people who maybe sat through this presentation to this point and are interested in adopting it and really transforming work with AI and ML, right? So a couple examples of this in the real world. First ML project I did, like production project, was summer of 2020. We had a big manufacturing customer, and they came to us and they said, "Hey, we need some help. We've got this. We're shipping a lot more stuff now, right? But we're behind on some of our data entry work. We've got to put this categorization code. It's called a UNSPSC code. I don't recommend reading this. It's quite boring, but very useful to businesses that need it for tariffs and purposes of identifying what you're shipping, right? They had 1 million parts in their catalog, and they had coded probably 10% of them. And they had people working on this for like a year and a half. They had 2 or 3 people, and they were doing like, what would that work out to be? I don't know, like 20,000 a month or something like that. And they're like, this is going to take us years to get caught up. We need it caught up a lot faster. And honestly, we don't want to hire more people to do more data entry. And we're like, okay, well, we think we could probably help you out with that. And they said, yeah, here's the thing though, we don't have a lot of money for this project. It's like like the person who came to us with the idea said, this is kind of leftovers in my budget and I want to spend it. And I think this is a good idea, but I really don't know what's going to happen. Nobody at my company's doing this. So we said, okay, let's see what happens. And kind of like the whole, like, I'm going to come up with a podcast thing, right? And see how it goes. So our hypothesis was like, well, can machine learning do this work faster and better and help them get caught up, right? We started with, let's go slightly more so you can see that. Okay. We started with about 30,000 parts, so a really small subset of their data. They had coded all of these by hand, so we knew the data was trustworthy. They really only had like 8 columns in the spreadsheet, and a couple of them weren't really usable. So it's really a small data set. But other than that, pretty high quality. There were, I think in that group, about 150 different codes. or classes. And they also had a default, or this is what it seemed to be. So I started my career doing some data entry work, and if you've done it before, you know that sometimes when you're repeating these steps over and over again, you have to make decisions, and sometimes you're like, well, I don't really know what this is, and I think I'm just going to use this code because it kind of covers everything. And they had been doing that quite a bit, and so they had one code that was like on almost a third of the parts. So it was a little bit of a problem. We had to consider that, but we're able to work around it. We used an accuracy metric to gauge our results, just like the one we looked at earlier. The proof of concept we built in about 4 weeks, it was around 78% accurate. And I talked to Pat Ryan, who I mentioned earlier, because we were working on it together. And he said, well, here's the results that I got. And he's like, And I was like, so I haven't done this before. Is it like really good, or is it bad, or is it okay? And he's like, I don't know. We'll have to show it to him and find out. And I think that's just stuck with me, because that's really kind of where you get every time you finish the process the first time, like we looked at above. Is this really good or not? A lot of times you don't know. So they were really happy with that, and they said that's way better than our manual folks are doing it. And so they invested in another experiment, gave us the full data set, and we did some tuning on our side, repeating that process a few times, and got the accuracy up to 90%. And they said, that's really great, but you're only showing us one of the codes, the one you're predicting. Is there any way to show, like, I don't know, maybe the top 2 or 3 the model thinks we should pick? And sure enough, there was, and it was pretty easy. And so we added that in, and if you kind of did a comparison of what the code was supposed to be and what the top 3 suggestions were, it was, I think there were only, I don't know, it was a really small percent, like less than 20 or so parts where the code was not in one of our 3 options. And so they would just take the predictions. They're running this in production now. It takes a couple hours, and it categorizes all their parts, and they just take that and load it back into their ERP, so that when the data entry folks come along, they can just pick which code they want from the 3 we're suggesting. They don't have to look anything up. They don't have to pause what they're doing. It's just a very, very quick decision for them to make about which one they should be using. So they were super happy with that, and liked it so much that we kind of took that same project, made a few modifications to it, and used it for another type of code. And they did the exact same thing. They'd run the data through a couple times a year and load it in, and then someone would just pick which one they wanted and move on with it. And I think that's a really good example of one, the topic of the talk, empowering people with machine learning and bringing it into some of their workflows, but also a good example of the like assisted intelligence concept, right? We're giving them, we're saving them a whole bunch of time in reviewing this giant, I mean, there's a few 100,000 codes in this list, right? They don't have to go and look at any of that stuff anymore, pause what they're doing. They just make a choice and move on. So for our first project, it was a lot of fun, and it went pretty well. I think probably the other thing that I think is interesting about it is that they only have to use it 2 or 3 times a year. So it doesn't have to be something that's necessarily like constantly maintained. They do have to make updates to it when they do that, but it's a tool for a specific purpose, right? Kind of like I was saying at the beginning. So, any questions on that one? I got 3 more. If we get that far, I think we will. Okay, next. This one's fun. Who doesn't like spaceships, right? So I was working on a big project team at a aerospace company, and we were kind of helping them, generally speaking, with process modernization. So they had some new crafts coming out that they were going to start testing soon, and they wanted to make sure that they had grown a lot over the past couple of years, and kind of had to shift out of the mentality of we're a startup, just getting something going, to, hey, we want to be a, more of a like grown-up company, and like make this a repeatable, profitable process, right? And so we're helping them out with a lot of different areas. One of the projects that we helped them with was around their flight card data. So to build simulations for the new crafts, they wanted to harvest data from past flights. A lot of the data that actually happened during the flight is captured on these documents that were scanned in after the flight. And the engineers were spending a lot of time locating the documents, because they were just on some server somewhere, literally opening it up, trying to do a find for the word they were looking for, flipping through a few pages. Each of the flight cards was 20 pages or so. So they were spending a lot of time trying to like pull out, like very small numbers, like I need to know how many, gallons of fuel were on the rocket, right? Because that has a whole bunch of important ramifications to how it flies, because it's like one of the main weight drivers, right? It's super heavy, and they burn it really fast. So how can we get these flight cards into a more usable format, save our engineers time, both now for what they're going to have to be doing, but then going forward, so they don't have to keep going back to these documents and doing that dumb searching process. So in this case, we ended up using a off-the-shelf tool. We'll look at this again, later case study as well. This is Microsoft Azure's Document Intelligence Studio. Really a nice tool, I think, for document processing. If you have data that's in files and they're like kind of similar, and you want to get it out, might be a good thing to take a look at. There were a couple of challenges with these documents, though. The first is, we asked them going in, we said, look, they got to be kind of the same in terms of structure, where things show up in the document, like which page they're on, what things are around them, the data points you're looking for, that really helps it be accurate. And they said, oh yeah, they're the same. They weren't the same. They had a lot of the same content somewhere in the document, but they definitely every year were changing what it looked like, what was on there. Sometimes even by flight, they would just delete chunks or paste in new chunks because, they were doing some other kind of maneuver for that particular test or whatever. So not super consistent. Another problem is that there were a lot of handwritten notes, and they said, oh, those are important because, it tells us some information from the pilot. And so we asked them about that a little bit and said, like, well, what do you mean it gives you information from the pilot? Like they write it down after the mission? And they're like, no, they got it like strapped to their leg, and they're like writing it while they're flying. And we're like, okay, I mean, I have a bunch of questions about that as a potential passenger, but I guess it's a test flight,
Pilots
so
are
fine.
always ballsy.
Yep. Right. Yep. I think that's probably part of it too, right? I we were joking about that a little bit. Where you're like, yeah, just fly the ship with your left hand and write with your right. And they're like, fine, no problem. you know. So anyway, sometimes they would perform a test and they would write a note in there like, oh, this didn't feel. There was a lot of pull, or they would put in some jargon or something like that collectively meant something to them that to us wasn't very good. And keep in mind, like, I don't know if you've ever tried to write and like just being in the car as a passenger, I find difficult. I'm not super coordinated, but I think that's difficult. And I couldn't imagine like one trying to do while I'm driving my car, but like how fast are you going in this craft, like hundreds and hundreds of miles an hour? And you're like, it's fine, I'll write something. Anyway, they weren't super legible, as you can probably expect. And they were not consistent where they would put the notes. It was kind of like whatever was in reach that would fit the word they wanted to write, that's where they would write it. So the results ended up being kind of mixed. We did get a bunch of key fields that they were typically searching for out. We put them in a SQL database so they could search for those. They had them. They could be easily just sort of queried and pulled into test cases as they wanted to use it. So some good results there. A lot of the fields that they wanted, we didn't get. I would say we probably only got like 30% or so of the fields they wanted. And it was just due to the different form versions being inconsistent. And then the handwriting was super inconsistent. And so we didn't have very good results with that. So questions on that customer. Kind of medium results there, but it's a very interesting project nonetheless. Yeah.
Bryan, do they continue to use this tool?
Yeah. Yep. In fact, there's a the new crafts. The whole reason this project and other similar projects happen is because they're starting to test them. So yeah, this is.
So this is a manufacturer?
No. It's a what's a good way to say this? It's a private space company, and so they design, procure, and then recollect the craft. So they don't actually put it together themselves necessarily, but they're sort of designing what it's going to look like and then owning it.
I would think even at the startup level, this is a highly capitalized business.
Mm-hmm. Yep, for sure. For sure.
I'm just so curious.
Yeah, I'm not supposed to. There's certain NDA stuff, so being recorded for ITKAN, I probably shouldn't go too far into that. But
no worries.
Next time I see you, I'll tell you about it. Don't let me forget.
Please.
Any other questions? Yeah. Other than who it is, because I can't answer. There's certain ones I can't answer. But the next two case studies we'll look at are both published, so I can answer a little more questions about that stuff. Okay, I'm doing pretty good on time too. I thought I was going to be light, but I got 19 minutes here. I got 2 case studies left. That's just about perfect. So when Pat asked me to do this, he was like, "Oh yeah, can you speak for our meetup in a few weeks and for about an hour?" And I was like, "Oh geez, I barely talk for an hour in a whole day." but I'll give it a go. So it
Oh,
worked out okay.
yeah,
Okay,
me
enough about me.
too.
Yeah, go ahead.
Nothing.
Okay, okay. All right. So another case study. College. Totally different from aerospace, right? This one's not even creating aerospace engineers. This is artists. So the Art Institute in Chicago is local, at least for SPR. And you know, the past couple of years, if you've been, you know, watching the news, following the trends, enrollment for higher education institutions is kind of decreasing a little bit. Costs are up, and so the school's kind of been seeing this a little bit. But beyond that, it's also had some frustrations with their assistance funding. So when a student at the beginning of, or I guess like, yeah, I guess it's the beginning of a school year, they start looking for people who are going to attend the next year. And they start compiling that list, and there's, you know, steps you have to go through, just like anybody else that's going to college, right? And you have to submit certain papers, and you have to get accepted. And then at some point, you have to decide to enroll. And so the gap they were seeing is they would accept students. They had to distribute some assistance funds by a certain point, but the students they were picking weren't always choosing to attend the school for a whole variety of reasons. And so they thought, hey, look, we have a lot of data about these students. Is there a way we can figure out when we get near the end of the enrollment period, what's a better profile for our student? Like, can we use the information we have about them to figure out who's most likely to come here, right? Before we start choosing how to distribute some of the assistance. And some of that's, you know, out of their hands, right? Like there's certain reasons, certain groups or students get other funding allotments, but they also have some discretion with that as well, right? So in this case, they gave us basically 1 year's worth of data. Here's all the students, about not quite 10,000 that enrolled and then, or sorry, applied, and that they accepted. And then our target was like, well, did they end up enrolling, right? And of that group, that's only about 1,400. So figure maybe 12% of them end up going there. Their data set had a lot of columns, and a lot of them had empty values. They were bringing together data from a whole bunch of sources to try to give us the best data set they could, and it was like still, again, for machine learning purposes, like we had to do a lot of weeding through it to figure out like what's actually useful in here. Yeah, one of their takeaways was like, man, that took a long time to kind of collect all this data. Maybe we should think about like starting this earlier, or how we store it, or sometimes it was like somebody would go to a open house, you know, like an open house kind of thing where they would meet students and they were just handwriting notes down about who they talked to or whatever, and they'd come back and not put it in, or put it in kind of sloppily. And you know, the saying, you know, garbage in, garbage out sort of applies there, right? If you don't put the effort in, you're not going to have something worthwhile later on. So really, we're just looking at figuring out, at least as a starting point, like how well can we identify a yes or no case of the person choosing to go to the school. Initial results were not very good, well below 40% accuracy. And fortunately, we were able to work with them on the data quality, learn more about what some of the fields meant. And what we found too was that The point in time that we were looking at the data was also very important. In fact, there's a this article right here about the project talks about that concept a little bit, where a field would be mostly empty, but by April 1st, between like March 1st and April 1st, they'd fill it in because that's when that data was available. And so the timing became kind of important too. Looking at it in between wasn't a good idea because it might be changing every single day between that period of time. Open, lots of change, closed. And so that was something we didn't think about at the beginning of the project. But the result, even though the score maybe wasn't like that magic, that you want of like, oh, just tell me which 1,200 people to give the funding to, right? And that's totally automated. What it did help them do was kind of like I said, figure out the characteristics of students likely to attend. And we put together these like almost like profiles, right? Like these are students who are likely to attend, these are students who are unlikely to attend. And that has had a positive influence on their usage of these funds and ultimately on enrollment so far this year. They're using it right now. In fact, if you watch the video, you'll see a familiar name in there because my brother works there, which is part of the reason we got connected with him in the first place. So I was talking to him about it the other day, again in prep for this, and he said, "Yeah, we're ahead of schedule, so we're happy with it so far." So good results there. Final results not quite figured out yet, but maybe if I'm back in the future, I'll offer an update on it. So questions on that?
Bryan, just
Yeah.
so I'm clear, this the Art Institute school's interest was in predicting who they should kind of salt the beach for or sand the beach for who might appreciate some funding, and that might incline them more to attend the Art Institute.
Yeah, right. And there's we didn't get into some of the specifics about like, well, how much do you have, or where does it come from, or how do you determine who gets what? That part was sort of out of scope for our purposes. It was more about identifying the people likely to come, and then on their side, they're pairing it up with funds that are available. So, for example, there might be certain scholarships or grants that the school has that it can allocate to, say, 10, 20 students, right? There might be 100 and students that applied that fit those criteria, and then they have to decide which of them might get it. So it's kind of those last few decisions. And if they go from hitting, let's say, 5 of those that end up attending to 6, even that's, broadly speaking, on that group of 1,400, a huge gain for them.
Yeah, but
And good for the students, right?
The monies are offered before the student makes the decision, correct?
Yeah,
Okay, got it.
have to be, yeah. Yep. Good
Yeah,
question.
I know that's the process always with either scholarships, etc. You know it as a student before your decision.
Yep. Good question. Thanks for asking.
I have a question as well, Brian. I'm curious, you kind of talked about how this project is, at the end of its first academic year of we'll call it production. And it sounds like it's going well. I'm curious if either you've heard of any like specific metrics that they've shared or know that they're gathering, or alternatively, because that's, maybe just not possible. I'm curious if through your, we'll call it back channels,
Yeah.
connection with the client, if if these, the like, what's the right word here? One of the takeaways from this project being like these student profiles, if that has had any other impacts within the school, like have they taken this idea of student profiles and used it in any other ways, or are there other groups within the school who are looking at this saying like, oh, okay, we see the potential?
Yeah,
Yeah.
Kevin, that's a great question. I was going to ask is this data possibly used to target students in ads, etc.?
Yeah, great questions. So I don't know a ton about their metrics. The one that I do know about that, my brother was sort of sharing with me was around they kind of measure things by date, right? So they want to see again, they've been around for a long time, right? And so they kind of know like, 90 days from school start, we should, or it's a little further than that, but let's say 180 days from school start, we should have this many enrolled. 150 days, we should see this many, and they sort of are looking at that for changes, and that lets them kind of forecast, the class size and things like that. So they're ahead of schedule on that at this point, and sort of predicting based on the trend that there'll be more usage of the funds this year than in the past. So that's kind of the positive that's going on there. Are other groups using it yet? No. In fact, one thing that came out of it that my brother shared was like it almost, and this kind of goes back to something Pat asked about earlier about machine learning changing people's jobs, right? Because they were using this predictive model, instead of maybe just doing database queries like they had been in the past, some of the reports that they had relied on didn't work because they weren't capturing the data the same way. And so my brother said, well, I went to this meeting and my boss was getting kind of nervous because, she's like, well, I'm used to behaving this certain way and all of a sudden I can't, even though some of the other indicators are like definitely positive. And so I think just in terms of like the mental shift you have to make sometimes in adopting these is like, yeah, there can be unintended side effects and they may be positive or neutral, but sometimes you don't always realize that that's what's going to happen when you start exploring it. So.
Yeah, thanks for sharing. And that even,
Yeah.
I feel like, ties back into the point you made earlier about a client who, is kind of like, wait, is this going to take my job? Like there's always these other sort of like workplace dynamics and sort of interpersonal side effects, let's say, from some of these projects and experiments.
Yep, for sure. Okay, 5 minutes left. I want to get to the last one. Now this one's the longest, so I want to make sure I talk about it briefly. It's almost like 2 projects, but we'll do our best with our 5 minutes. So this is something, like I said, Kevin and I just finished up working on this project actually. This is for the VGM group. This is a published case study. We've got a link down here, and actually one of our teammates, the link's in here, one of our teammates is actually writing another related post about it. So I know there's going to be at least one more. There might be even more than that. I'm not sure yet, but basically they're offering insurance. They have a number of business units, but one of their business units is focused on insurance for healthcare providers that deal a lot with small to mid-size. Sorry, I missaid that. They deal with insurance for small to mid-size insurance providers that are usually focusing on things like physical therapy, home health equipment, or home medical equipment, home therapy, those kind of things, right? Inflation's affecting everybody. I know my insurance has gone up just from that because claims are more expensive. And so insurance companies in particular are looking to machine learning to start thinking about like, hey, how can we figure out like if or when a claim might be caused, right? So we actually had two problems to kind of solve here. We wanted to answer that hypothesis, but to do it, they thought that the customer's application that they filled out when they applied to get coverage was going to be like a wealth of information. So they had like tens of thousands of these like contracts, and they're all in PDFs. A lot of them are scanned in. A lot of them are handwritten, although they're better than the pilots doing it in the ships for the most part. I think Kevin looked at a few more than me, but I would say the ones I saw were better than the flight cards at least. But there were a few questionables. Anyway, so we really had to get all that data out into a usable format. Another challenge that we had with this is that by nature, insurance is supposed to be kind of like a unexpected event, but we're trying to predict when it's likely to happen. And so in their data set, at least, they had a really small percentage of examples of contracts that had yielded a claim. And so there's a machine learning concept for that called overweighted. In this case, is extremely overweighted. And so there can be some challenges in like just getting enough samples to train a model to kind of do a decent job, right? There's a few different metrics we used. I won't get into this because that's not the most interesting part. The piece that I'll say about it is that the model we ended up building for predicting the claim risk had multiple metrics. And so sometimes what you need to do based on what you learn about the business needs is measure a few different things as you're tuning the model and making decisions. And so we had this one in particular, this precision metric. We met with their underwriting team and they said like, yeah, we typically prefer having a few more customers with a little bit higher tolerance for risk than less customers and less risk. And so we took that into consideration as we were building the model. And that's an important thing to keep in mind as you start trying to use them in a business context, is the sort of business environment about what's happening right now, right? Okay, so results quick. The extraction process, super successful. Kevin really spearheaded this. He did a great job with it. We used Azure Document Intelligence Studio again, just like with the flight cards, but these were way more accurate than those were. And we got almost all the data we wanted out of there. Very high accuracy, due partially, like I said, to the fact that a lot of them were better quality, slightly more consistent than the flight cards were, less random handwriting all over the place. However, even though we got almost all of it out, it didn't end up making a good model. And the reason it didn't is that they were changing the form every single year. And so there would be questions on there that would move around. They would fall off. They would reword them or take one and split it out, or take 3 or 4 and condense them. And so there was no consistency across those versions of what was getting answered. And the customer wasn't really, from our perspective anyway, being forced to fill out most of the fields. So we ended up with this data set that they were really insistent on it was like going to be key to making this magic happen, and it just didn't pan out that way. And so they learned a few things from that in terms of how their current processes were working, and maybe like which fields they actually needed to make some business decisions. So interesting takeaway from that side. The model we ended up building, we did a bunch of different versions with different combinations of customers. Ultimately, we got down to like 6 or 7 fields that we knew we needed to include in the model. This thing's going into production like this week or next week. I think they learned a couple things about, well, let me say this a little bit differently. I think this is probably their key takeaway, which none of us really expected going in. But what they realized is that almost half of their business, half of their contracts were low risk or very low risk. And so they took our predictions and just sort of broke them into different like risk buckets, is what they were calling them. And now if it shows up in one of these low buckets, they really don't have to spend nearly as much time in the underwriting process because they can feel confident based on all their historic data that these don't need there's not a lot you can do with it. Like, could a claim still be caused here? Yeah, but statistically, it's highly unlikely. The team can spend their time digging into and spending more time on maybe the higher risk or potentially higher risk customer group. So not exactly the magic prediction they were looking for, but also very formative in improving their current business process. So questions on that? That's my last one too.
Well,
you can ask general questions if you want.
This was great, Bryan. I learned a lot, and one point that I think you made at the outset is that due to the process of developing an ML AI project, it's not as deductive as a typical project where you put in inputs and you anticipate expected outputs.
Mm-hmm.
While there's some elements of that, as you made very clear, often you learn different things than your postulation might have led you to believe.
Yep, definitely. And that's for most of these the case. I think the first one is probably the closest examples to, yeah, that kind of worked the way we wanted. And the rest of these were changes to their original hypothesis, but ended up having positive impacts for them in a variety of ways.
Yeah. And the second thing I'd say, if I'm reading this correctly, you, Kevin, and the team really knocked it out of the park on the last on the insurance company in terms of the accuracy of the data.
Yeah, good. So just to elaborate on that a little bit, I think you're giving us too much credit. So even though our model accuracy, our overall score is at 97%, the problem is that the claim ratio is around 3%. So really, we're just like, there's this concept in machine. I told the guys this too when we did the project. There's this idea that we call a dummy classifier, and it's the idea is really, hey, if I just guessed one answer every single time, how often would I be right? And so if you were like, no, there's not going to be a claim every single time, your accuracy is going to be right around here, right?
Oh,
And so what we had to do then is look at, and this is part of the reason we had multiple metrics, is we wanted to see that, hey, these other ones are going up. That's telling us that we're getting closer to dialing in on the right signals that the customer is looking for. Even though maybe we're not going to get over the 98% mark, we can at least tell that it's making more right decisions than wrong decisions, or it's making a reasonable number of right decisions. So it's dialed in pretty well. I don't know if you want to add anything on the project, Kevin, since you're on the call.
Not exactly. I think you did a really nice job kind of laying out the business problem, kind of what we did to address it, and how, again, the results were maybe not what they expected or what they thought they were going to get, but were still useful. I think to Pat's last question about the 97%, that was also considering their whole customer base. And so there were different customer groupings within their, I think we looked at, like, I forget what it was. We'll say like 30,000 clients or something like that. They had some specific number of customers that we looked at, but that the groupings of those customers. So let's say, like, physical therapy customers versus nurses, staffing customers were not evenly distributed. And so we also found, there was a whole aspect to the project that was trying to look at, can we get better accuracy within one of those subgroups? And, there was that, like, kind of like Bryan was saying, there's a lot to unpack with that 97%.
yeah, got it. Thanks, Kevin. That clarifies something.
Okay, well,
does
I'm gonna.
anyone else have a point or a question for Bryan or Kevin?
This has been great.
Yeah, thanks so much, Bryan, for the investment of time in advance and a great presentation.
Thank you.
Really enjoyed it.
Thanks.
Yep. Thank you,
Thanks for
Bryan.
having me.
And thank you, Kevin, for joining us as well.
Thanks. You're welcome.
Thank you.
Bye, guys. Have a great evening.
Thanks,
Yeah,
Kevin.
you too.
Bye.
You too. Bye, everybody.
Okay, bye.
Take care, everyone.
YouTube on.